It's super great and awesome that we now have a massive API that we can theoretically use to do anything with YouTube. But the problem is that all this code in here is entirely untested. I mean, sure, it does compile, and the test cases that are in code, they do compile. That's easy. Because it's all made by the same generator, and I paid attention to a few things. But still, I have no idea if it works, if it communicates to the Google server, because I've never done that really. There are so many things that can go wrong, and I really want to use it easily. This means I don't want to be forced to write a program. I just want to use the command line to do this. Like so, YouTube 3, do something. Do something cool. That's what I would like to do. Yeah, I think the only real way to do this is to generate a command line interface as well. So initially I wanted a YouTube uploader, and now I end up with a fully generated generic program that will support all the features that I want, but not only for YouTube, but also for Drive. So let's see how we can handle this with our current build system. After all, if we call make, yeah, it might actually reinitialize itself because I went back in time to show you the current state. If we call make, you see that right now, actually we only support one particular piece of thing. I mean, you see this here, right? It's totally obvious. Yeah. So the thing is that we generate all the API dependencies using this macro script here. And right now it has no notion of what it does. There's just one program that it will ever build, and it kind of knows that it's an API. But now what's happening is that here we also want to have a command line interface. And not only that, maybe even more. Maybe I want to have a graphical user interface at some point. I won't exclude that per se, because lots of cool things are happening with Conrad, for instance. So how would I do that? Considering that this piece of code here is doing the API stuff, maybe I can have another piece of code to give me the CLI stuff, right? So that's the basic idea here, because what I don't want is to try to hack this in, because then you only support two things. It's kind of duplication of the same thing all over again, and I generally don't like it. In order to do this, the only thing that has to be done is to have this, to take away this shared YAML, well, not take it away, but to split it up into the portions that are only useful for the API and make up some other portion that is only useful for the CLI. Something else to think about is documentation, right? As I said many times before, and I will say it many times again, documentation is a first-class citizen, and we really want to get it right. This is pretty, but for the command line interface, even though I don't yet know how to properly do that, we need documentation as well. But we can't, unfortunately, use Rustdoc. We need something else. And Rustdoc, has support for Markdown, which is something I really like. And I mean, GitHub uses Markdown as well. Everybody uses Markdown nowadays, and this has a reason, for good reason, I'd say. So I'd like to have a system that supports Markdown. And in addition to that, if you look at this, you'll see that I'm kind of a Python guy here, because Mako is Python. My entire non-Rust toolchain is basically Python. And I think that's a good thing, because I know how to use that. And even though I don't like the Python environment as a whole, I at least make it work for me here. And, that's it. It works. Could be anything else. But this also means that I'd rather have a tool that fits into that toolchain so that I can easily install it. Solution is this here, MakeDocs. It's pretty awesome, because it's super simple. It's actually not awesome. It's super simple, and it doesn't do many things that you probably wanted to do. But there's this one thing that it does right, which is building your documentation based on themes. You have a very simple structure. There's not much to it, but that forces you to kind of keep your documentation clean, and then you just say, hey, I would like my docs to look like this or that, and that's it. So super easy to use, and that's something I also want to be having. And we have to remember this, because we want to upgrade our build system here in order to support that as well. Two different documentation build systems, basically. The solution was to pick out all the data from the shared YAML file into its own called type API. That way I have a separate file that allows me to specify how exactly APIs should be built. The same has been repeated for the command line interface, which looks a bit simpler than the respective API, as you can see. The shared YAML is now shared among all the program types that there are. And now the name actually makes sense if you think about it. In the main and handwritten Makefile, there's a bit of redundancy going on, as I just decided to basically hard code the invocation. So what we do is we create two different API or two different Makefile dependency files with two invocations of the Makefile generator and the respective file list, So when this is generated, it looks very much like so. So we have a different one for the CLI that defines all the command line interface targets, and one for the API that defines, as previously, all the API related targets. As you can see, the documentation engine is now something that can be configured within the respective YAML file. So here the documentation engine is MakeDoc, so the command line interface uses a different one than the API, which still uses rustdoc. The keys here that are used, they are kind of duplicates to each other. So if we would pull in all the files together, they would override each other. But in fact, we select the file that we want to pull in and merge it into the big data tree that then defines the state of the generator. So there is no clash whatsoever. This also means that I can now easily create the command line interface docs by just executing the respective targets. It's knowing all the dependencies, so it will build the API before it generates the CLI code to finally kick in the Makefile generator, the Makefile generator, which in this case creates the very first version of our MakeDocs documentation. Now that we are able to build command line interfaces, command line programs, and build the documentation for them, we just have the very foundation for our actual work. So what if I wanted to insert a video using the command line? I mean, what I would basically have to represent is, or what I would have to get in the end, is a call like this. Look at that. I'm setting up a hub. Okay, here I assume I have it already. Then I'm setting up a video request structure, and here I just, initialize it with bogus default values. But of course, this is not just a simple structure, it is a nested structure. And then I set up a call that puts in the required parameters accordingly, and may have some optional parameters as well to finally, open or upload a file in a certain manner. Which also means that I need to open files and, gather a lot of information and all that on the command line. So at the first glance, this is the simple part here, the part where we have the optional parameters, because they look rather straightforward. That thing here is more difficult. It requires us to set a nested structure without going crazy on the command line, and ideally without having to use external files like JSON that contain that structured data. Not initially, at least. So two things to this. First, we need to parse our command line arguments, and that I really want to hand off to somebody else. I don't want to deal with that. Not that I couldn't do it or haven't done it or haven't written a command line parser myself, but it's really nothing I want to take care of because that problem has been solved many times. So back in the days when I had the choice, I chose docop because it allows me to basically just generate a string like this. A string with the grammar of the command, which is cool because the grammar is kind of standardized and useful, or many people can read it by now. And not only people can read it, but also the docop parser, which at compile time generates the parser as well as a structure that will then contain all the flags that I've defined here. That's pretty cool. So in the actual code, somewhere way down here, all I do is, somewhere here, that's basically the lines that decode, that deal with handling the argument parsing. Actually, it's just a single line, this line. And that's really what I like about it. It's really simple. What I don't like about it is that even though it works, if you try to use, for instance, YouTube 3 here, videos insert, it doesn't tell you anything if it doesn't like it. It only tells you invalid arguments up there, and then it shows you the usage, which can be massive. And I can't really help it, you know. It should actually tell you that it requires a part. Oh, sorry, it doesn't require a part. It requires some request values here and some information about the file to upload as well. You know, and this is, you know, something we have to live with for now because it works. That's the most important point, and I didn't have to invest a lot of time to get it to work. So yeah, I'm quite happy with that. And for the first version, it's totally all right to do it that way. Let's talk about the difficult thing. The difficult thing is to somehow use the command line to set very deeply nested complex structures with lots of possibly optional values inside of them, and, you know, doing this correctly with a static type system. So there's no way we have a dict underneath and do it that way. No, we have to kind of fit it in the actual structure, which looks very much like this. If I click here, you see that it's optionals of nested structures that can have, you know, optional other things as well. So basically it's all optional here. That's how this has to work right now. Unfortunately, I had another version that kind of used optionals only when I thought it would be needed, but the server reply will occasionally leave out fields, and right now the only way I can represent this is through optionals. Anyway, how do we possibly do that? Well, here's the documentation, the final documentation for the first release of the command line interface. So it's, you know, very close to what you actually get. Actually, it is what you actually get. And what you see here is that the request structure is fully laid out for you. So all the nesting here is just laid out in a YAML-like structure. It's YAML-like because I think, well, it's actually YAML. It is valid YAML, if I'm not totally wrong, which is pretty neat. But not only that, it will also show you how this can be set. So what if you wanted to set the entire structure from top to bottom? What kind of flags would you have to set? And this is what the documentation shows you. You know, it shows you the -r flag for request structure, and then this kind of fancy key value definition, which basically says, okay, we start at an absolute key and set the age rating here. Ooh, and see the space? It's hard to see here, but there is a space in between, and that really makes all the difference. Because if we set something that looks like only a key, we set the cursor. So here we set the cursor to age rating. This means if we go up, 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 we will now be setting all the fields within the age rating structure. If we go down again, you see that now we can just go ahead with alcohol content is true, restricted is false, and, you know, that's just random values here. Probably shouldn't read them. And video game rating set. So now we have we've set all the three values or fields within the structure. And now we have to get out of there again. How do we do it? We could start from the top again. We could just use such an absolute value or such an absolute cursor representation. Or, because I want to show all the possible things that you can do with cursors, or you just go up again. And that's the dot dot notation. So dot dot goes up one level, dot 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 goes up 2 levels, and so forth. And then we go down 1 level again into content details and set caption to this value. So how does it look like? So now we are basically here and go up 1 level, go into content details and set caption to string. Look, content rating. So now we would have to go down again, which looks like this. You have to realize that this -r is just specified once. The rest is just values. Otherwise, the argument parsing will be confused. You know, I mean, it's done in a way to allow you to not repeat the dash all the time. So this content rating sets the cursor to the content rating substructure, and then we go ahead and set all the structures and so forth. This is how that works. I mean, maybe I can show even more interesting things here by just looking at them. No. Maybe not. I think at the very end, there might be some even more complex stuff happening. Well, not really. We just go up and down a little. But that's how this basically works. And cursors allow you to very efficiently set nested structures on the command line without going crazy. Obviously, you can't set all the values. You can only set values that boil down to either pods, strings, or vectors of pods. So there are certain types like nested vectors, for instance, that you cannot specify. But nested vectors, most of the time, I think you wouldn't have to set anyway, and I will just leave them out of here and not list them at all, which could be fine for most cases. In the real world, this looks much like this. I have the YouTube 3 command. I want to insert a video, and this is still kind of a bogus call, but I'm setting the structure correctly. So here I go into the age rating structure, set all the fields, or some of the fields, go up again, go down into content details, set the caption to foo, and then I just specify I want a symbol upload of a file that doesn't exist, that is of type MIME type application octet stream. Yeah, I kind of did it intentionally so that this will not actually call the API, because if you do that, I am totally trying to use a token that has been revoked. And I think now it will ask me to authenticate, which I will just not do in this case, because it's not part of what I want to show. Yeah, well, as you can see, I actually did authenticate and I executed the call, because why not? And yeah, it tells me that it didn't like this call for a reason that I totally don't understand. Now that we have generated all the code that is needed to allow us to control the API from the command line, it's just about building them, right? Well, building is kind of an important topic. I'm just letting this build in the background here, even though I don't think it will finish when I'm finished talking. All I have to say is it takes a long, long time. So YouTube is one of the bigger APIs with a total of about 40,000 lines of code. Well, not lines of code, but you get the pointer. It's like 40,000 lines and maybe like 35,000 slug count. Both CLI and API together. And it just takes like 4 minutes 30. And I just say without the dependencies, by the way, just the CLI. I say just because it's still quite acceptable, because usually during your workflow, you will rebuild the CLI. And for most testing purposes, I can also work on smaller command line interfaces out there. And I definitely do that because otherwise it just takes too long. But if you go into release mode, which I did just recently, then YouTube will build in 45 minutes. 45 minutes for one build, which is kind of crazy. I mean, sure, optimizations really crunch the executable down to just a few megabyte, 11 megabyte in this case, and it executes very fast. And if you have a debug binary, it kind of doesn't execute very fast for some reason. Or not a debug even if you don't optimize fully, like optimization level 2 or 3. So I'm just saying it just takes a while, and you want to invest that time for your deployments, because the executable will otherwise not feel as snappy as it feels right now. If I execute this YouTube 3, it just takes 0.047 seconds to get started here, and otherwise it's up to 0.5 seconds to show you the result. For some reason, I don't know, maybe it's, it says it's a system that uses so much CPU, and I have no clue what that could be. But all I'm saying is compilation time wants to be managed a little. And for the release here, I had my machine running for like an entire night and had a virtual machine running in the cloud on 2 cores that was building for like 24 hours, because it's obviously slower than my dedicated CPU I have locally here. Quite amazing, but also fun, and I'm sure that with the release of Rust 1.0, things will improve a little bit. I've read about improvements they have already made, but which are not enabled for the nightlies, and for some reason I have the feeling that Rust C is in debug mode, because the LLVM binary, the LLVM shared object to be precise, that Rust C uses is 50 megabyte in size, and 50 megabyte shared objects usually are only there if it's some debug mode thing. So yeah, that is that. Let's see where this ends. Compiling on Linux is not easy at all, just because the machine needs quite some power to do that. So I just have virtual machines here, and I also have a cloud VM that can do a lot of stuff, and it's always busy compiling release builds here. But certain things it can't compile, because this thing only has 2 gigabyte of RAM. And I mean, look at this. I'm compiling YouTube and Drive 2 here, And as you can see, it goes up to 2 GB easily. And then when it tries to start the linker, for instance, this needs memory as well. And then usually things go wrong. So even though I would hope that I can just let this thing go for this virtual machine in the cloud, go for 2 days or so, and then all the release builds are done. In fact, there are certain things that I just can't compile there because it uses so much memory. It's incredible, but I deal with it. I make it happen because, I want it. Of course, no diary entry can be complete without a little demo. So let's try to upload a file onto Drive. Let's go there. I hope this will work. Okay, so here are my files, totally awesome. And I'm going to upload a file now. I think, so the most difficult thing about this is the scope, because the default scope just doesn't work for some reason, and it tells you you're not authorized to use the standard Drive scope. So you have to do this, and I've found this on Stack Overflow, by the way, so that's kind of special. So files insert is this, and if I want to look it up, then we need some structure, some request structure, and then the kind of upload we want to have. So let's try to get this done. So it's -r, and then we have a title, which is readme.md, and the MIME type shall be application. Oh no, let's call it text plain, right? Text plain, I think that does exist. Now the upload type, it's simple. We don't want a resumable upload here. Simple is just enough for a text file. Then the file itself, I'm just going to pick this one here that is right in the root of Google APIs RS. And then the MIME type of this thing. The MIME type here is that I specify here is relevant to the HTTP protocol, not to Google Drive. So application octet stream is kind of the default that will always be fine. So in theory, that will actually do an upload. I'm also uploading other stuff, so it's kind of slow, but still. And in theory, again, things pop up here any second now. Because this upload worked, so you can see that my result is 0 here. And it will give you all kinds of information about the new file. Also, its ID. Where is it? Where is the ID that it is supposed to give you? Any second now. Here it is. So that's important because you are going to deal with these IDs a lot if you do this. So first of all, here we have our file. And I think I am able to look at it and it will show me some sort of preview. There we go. So that's some beautiful markdown there. And if you want to get rid of it, I think all you have to do is to say files delete, and then you pass the ID. And this will, any second now, delete the file circumventing the trash, which you would usually have if you would do that. Well, there we go. So that updates automatically. That's very nice. And I would have loved to show you some better demo with YouTube and uploading a video, but considering I have no progress reporting right now at all, this is coming up for the next milestone. It's kind of boring to look at that anyway, but it would work similarly. So here, this Drive example is, I think, a nice, concise way. And what's up next is basically improving this command line tool to support queuing. And of course, delegate callbacks so that you can do stuff when uploads have succeeded or failed and things like that. So lots of stuff is going to happen. Stay tuned and thanks for watching.